Now that you know all about the eyes, let's move on to the ear. We'll begin with the parts of the ear. The ear is divided into 3 areas: the outer, middle, and inner. The outer ear has the pinna, or also called the auricle. This is elastic connective tissue. Covered in skin. This is the part that you see on the outside of your head. In humans, it doesn't really serve much function. To some degree, it can help funnel sound in. But that's kind of minimal. It's not funneling a whole lot of sound in. In other animals with larger ears, it does do more to funnel sound in. It can also, in other animals, be used as thermoregulation, like animals that live in the desert has really big ears. The blood flows through those ears and it cools the blood off. It kind of serves as an air conditioning. And it can be used as communication. Think about like a horse or a dog. They lay their ears back when they're angry or upset. But in humans, it's not really doing much. Then you have the ear canal. This is also called the external acoustic meatus. This is the tunnel into the temporal bone. So you can see this bone here. This is the temporal bone. So the ear canal is the tunnel into your temporal bone. And this is where earwax is made. So this is where you have ceruminous glands, and if you remember from back in chapter 6, these are modified apocrine sweat glands. This is the source of your earwax. And the purpose of earwax is to protect your ears. Earwax is sticky so that it traps dust. And I know this is gross to think about, but the book should actually list this: insects. So they can't crawl down into your ear. Then the last part of the outer ear is the eardrum. This is also known as the tympanic membrane. So this creates a seal between the outer and middle ear. So as long as it is intact and functioning right, water or air cannot get through. It is a tight seal. Nothing gets through there. Then we can move on to the parts of the middle ear. The middle ear occurs in this cavity in your temporal bone. So here you have a cavity. And this cavity is filled with air. So it's important to maintain air pressure on both sides of the eardrum. So you have the eustachian tube. It's also called the auditory tube. This connects the middle ear to the throat, or the pharynx. And it lets air in and out. And the purpose of this is to equalize air pressure on both sides of the eardrum. So this is why you hear popping, like when you go up in an airplane or up in the mountains or a tall building, you hear popping. That popping you hear when your altitude changes is this tube opening and closing to let air in and out. So when you go up in high altitude, the air pressure drops. So the air pressure on the outside of your eardrum would be lower. You therefore have to also lower the pressure in your middle ear. So you have to open that tube and let air out. And that's the popping noise you hear. Also, within the middle ear, you have these bones. Right here are 3 bones called the auditory ossicles. These are the 3 smallest bones in the human body. And they are the malleus, incus, and stapes. So this one is the malleus, this is the incus, and this one is the stapes. Their job is to transmit sound waves, and they also amplify them. Then we're ready to move to the parts of the inner ear. This part here, that looks like the body of a snail, is the cochlea. This is the part that hears. Then you have the part that looks like the head of the snail. That is the vestibule. This is where your sense of balance comes from. So this is your static equilibrium. So equilibrium is another name for your balance. Static means you know which way gravity is, you know if you're accelerating or you're decelerating. Then up here, what look like these crazy antennae on the snail is the semicircular canals. These give you rotational equilibrium, so they know when you're spinning or turning. Couple of other important parts here. Right here where the stapes connects, that spot is called the oval window. This is what receives sound waves from the stapes. Then there's another spot right about here called the round window. And this is what dissipates the sound waves after you have sent a signal to your brain. This way you don't hear echoes in your head. So there's an overview of the parts of the ear. We're going to look a little more at that eustachian tube. The eustachian tube is a very important role in ear infections. If you think about ear infections and who gets them, they're common in kids and rare in adults. If I draw two simple faces here, which one's the baby and which one's the adult? Even just from these basic, simple stick figure faces, you can tell this one is a baby, this one is an adult. Babies have a round head. Adults have an oval head. The difference between having a round head and an oval head determines your eustachian tube. In a baby with a round head, the eustachian tube is horizontal. As you mature, your face gets longer. It grows in the up and down direction. So your face getting longer pulls that tube down to an angle. So here in an adult, the tube angles down. Now, if you have kids or you've been around kids a lot, think about what precedes an ear infection. They don't usually just suddenly out of the blue wake up and have an ear infection. They get an ear infection after they've had a snotty nose. So ear infections tend to follow something going on in the nose, a cold or a sinus infection. So usually the infection begins in the nose. Then migrates to the ears. The reason ear infections tend to follow nose infections is because of that eustachian tube. In a baby, that infection can easily migrate up that eustachian tube into the ear. Another factor that makes kids so prone to ear infections is behavior. Think about what a toddler, imagine a 2-year-old. What do they do when they have a snotty nose? Do they blow their nose? No. Kids don't like to blow their nose. In fact, they're terrified of Kleenex. If you ever have a 2-year-old who's bothering you and you want him to go away, just grab a Kleenex and say, "Hey, let me wipe your nose." He will take off running and hide. Kids do not like to have their nose wiped. They do not blow their nose. So they also have this behavior in which they snort that snot up. And so every time they do that snorting thing, they send that snot right into their ear. They're giving the infection a free ride to their ear. Adults rarely get ear infections. One reason is that tube is angled down, so it's hard for the infection to migrate up into the ear. So it drains because it's angled down. And also, adults will use a Kleenex and blow their nose. They don't tend to snort. So they're getting that infection out rather than snorting it straight into their ears.